Here we'll do some more practice with means. Now we have a long question to read here, but let's look for the word claim. We're going to test the claim that the new machine measures a mean of 9 grams of yeast per batch. Now, we didn't see any less than, or greater than, or at least, or at most. So, the only thing left is equal to. Also, it's stated that this is a mean problem, so we'll use mu. Because we have no comparative terms in here that would indicate less or greater, we would use equals. So we can say that mu equals 9 will be our claim. And since we have equals in this, this will be the null. Let's write the opposite hypothesis as well. The alternate hypothesis would be the opposite of equals, which is not equal. We still use mu and 9 for our symbol and our number. Our possible outcomes here are if big P is less than or equal to alpha, that means we have strong evidence, and reject the null hypothesis. Now imagine if we crossed out the null hypothesis, we would also be crossing out the claim along with it. Therefore, this would result in rejecting the claim. Now, if big P is greater than alpha, we have evidence that is not strong. In that case, we fail to reject the null. And in that case, we would have to box it in and keep it. And in that case, we have also failed to reject the claim. With that in mind, let's calculate our test statistic. Our test statistic from step 4 involves x bar, mu, s, and n. We can make places for those in Excel. Now bear in mind that x bar is the sample mean and mu is the claimed mean. S is the standard deviation and n is the size of the sample. Now let's go through the question again and look for a sample mean. Here in line 4, it tells us we have a sample of 8 batches, a mean of 7.89 grams, and a standard deviation of 0.5 grams. So for my x bar, I'll place my sample mean, 7.89. My claimed mean, from my claim, I'll use 9. The standard deviation is 0.5. And we have 8 batches. That would be the size of the sample. Based on that, we can calculate our test statistic. We'll say equals, parentheses, x bar, subtract mu, divide by, another parentheses, s, divide square root of n. Close the parentheses twice, and press enter, and this gives us our test statistic. Now that we have the test statistic, we calculate big P. We'll make places for that as well. The left-tailed big P will be t.dist. Click the test statistic, comma, n minus 1, comma, true. For right tail, we would do 1 minus the left tail. And for two tail, we would say 2 times whichever of the two tails is smaller. This gives us a two-tailed value of 0.000412. Now, to figure out which to use, we look to the alternate hypothesis. Just as a reminder, if your alternate hypothesis is less than, we would use left tail. If it's greater than, use right tail, and if it's not equal to, we use two tail. Therefore, our big P will be 0.000412. Now let's compare that against alpha. Now our big P value was 0.000412. Alpha was 0.05. We can tell that our big P is definitely less. Therefore, we'll go with the first possibility. We do have strong enough evidence to reject this claim, so we'll cross it out. we can say that we do have strong enough evidence at the 0.05 significance level to reject the claim. Now we restate the claim, and we'll remember that our claim was that the batch size is 9 grams. And so we've talked about our evidence, we've talked about the significance level, we've talked about what we're doing with the claim, and we are restating the claim. Once we've done all 4 of those things, that's all we need to say here.